Good morning, everyone. So today we're going to focus on some things that we learned last year. We're going to do law of sines. We're going to go over the right triangle stuff. So the other thing we need to note is that today, when we use our calculator, because you will be able to use your calculator, you want it in degrees. Now, depending on what calculator you have to figure out how to change that. If you don't know how to change that, look up your calculator on the internet and put in change to degrees. Mine, I just go to mode and then I put it in degree. Now, when you put it in degree, it stays there until you reset your calculator or you change it back to radian. So depending on what you're doing for math, you might double check what you really need, radian or degree. Alright, so the first thing we're going to do is remind ourselves about solving for a right triangle. With law of sines, law of cosines, trig, formulas, anything like that, SOHCAHTOA, we're able to solve for missing sides and missing angles. And this is what it actually wants you to do. It says, given a right triangle with a hypotenuse length of 7 and one leg length of 4, find the length of the remaining side. So we're finding the length of the remaining side and the measures of the remaining angles. So in our right triangle here, we've got our hypotenuse labeled as 7, a leg as 4, and our right there, the angle, of course, what does that mean? 90 degrees. So we are able to use our basic right triangle trig to help us solve for each of these. To solve for the missing side, hopefully you were thinking to use Pythagorean theorem, so we'll set that up as a squared plus 4 squared equals 7 squared, and I solve all the way through. A squared plus 16 equals 49, subtract 16 from both sides, and then take the square root. Now usually when we take a square root we have plus or minus, but because this is talking about length, it is only the positive. Alright, so that was our length. We need to find our angles. Well, a good way to find our angles is to use trig, or to use our SOHCAHTOA. So let's look at alpha. We're going to solve for alpha first. Well, alpha here, I always want to use what's given to me, because if I made a mistake with A, I would make a mistake with everything else. So that means I have the adjacent side and the hypotenuse, which means I'm using cosine. So cosine of alpha equals 4 over 7. And then I know to get rid of cosine, I have to do that inverse. If I wanted exact, I would keep it as this. But since I'm okay with getting the degrees and rounding to the hundredth, I just go inverse is second for me, cosine. So I want to make sure I get that -1 in there. 4 divided by 7. And the 100th place is the second decimal, so I've gotten approximately 55.15. Now, because I have alpha, this makes beta a lot easier, because beta and alpha together should equal to 90 degrees, because I know that all three of these should equal 180. If all three of these is 180, I already have 90. These two are 90. So all I have to do is 90 minus my 55.15, and I get 34 beta, 34.85. Did anyone realize that I did not put equals down? Because if you remember, 55.15 is an approximation, so I am also going to show that I am approximating 34.85, and these are both degrees. Alright, so that only works if you have a right triangle. So what if you don't have a right triangle? Well, one situation that we are able to use is called law of sines. You might have saw this last year. What it's saying is that the side and its opposite angle, opposite pairs, are proportional to each other. Now, they give us two equations here. Either where the angle is on top and the side is on the bottom, or the side is on the top and the angle is on the bottom. This actually works for depending on what you're actually solving for, because a lot of us don't like solving for things in the denominator. So automatically put your unknown in the numerator and you'll know which way to go. My other suggestion is if you put a side in the numerator, all your sides are in the numerator. Okay, so we're going to go over a couple situations. Angle, angle, side. So I want to show you what that means when I draw it. So of course my triangle is not going to look the best, but really what that's saying is that I have two angles next to each other, and I have the side after that second angle. I don't have the side in between. That would be angle, side, angle. No, this is going to be angle, angle, side. Now, here is what I do. The first thing I keep in mind is that I'm going to want all angles, so alpha, beta, gamma, and I'm going to want side A, side B, and side C. Okay? The next thing I'm going to do is actually write down what's given to me. I am going to write this down in another color so I know what's given and what I'm solving for. So, I'm given alpha, I'm given side A, and I'm given beta. Again, two angles, one side. Alright, so let's think about it. What can we solve for first? Well, we can solve for that angle first, because all three of these should add up to 180. So right now, to find gamma, so I'm going to write down my work so I know where to find it later. To find gamma, I'm going to say 180 minus 120 minus 45. And I don't need to approximate there because I know that exactly equals 15 degrees. And then I'll put that in my list. See how I did it a different color so I notice what's given to what I solve for. Alright, the next thing I'm going to do is solve for my sides. I'm going to use the law of sines while doing this. So the first thing I'm going to do is solve for side B. I said before to always put your unknown in the numerator. So I'm going to put my side in the numerator, which means I have to do the angled pair, which is beta. So I go sine of beta, which in this case is 45, equals. Now I must use another pair, because if I used gamma and C right now, I would have two unknowns in my equation. So I'm going to use my A, my alpha. Now this is the side on top, so I'm going to do 7 over and sine of that angle, which is 120. And now how do we get B by itself? Well, I just multiply each side by sine of 45. when I put that in my calculator, I want to make sure that my parentheses are correct. So I'm saying 7 sine 45 divided by sine of 120. And I get, remember, if I'm rounding this to the second decimal place, it's going to be 5.72. And I'm going to approximate that, right? 5.72. So I'm going to change that equal to approximation on my list. And we're good. Now, you cannot use the Pythagorean theorem here to find C. You must find law of sines. Use law of sines. You cannot use the Pythagorean theorem because it is not a right triangle. So we're going to have to set up another ratio. So we're solving for side C. That means the pair is side gamma. So sine, or angle is side. Angle is gamma. So sine 15 equals. Now you can use the pair of alpha and A or beta and B, but really what's the better choice to use? Alpha, because that's the pair that's given to us. If I had messed up for my side B and I used it, I'm automatically going to mess up on my side C. So I'm still going to use 7 over sine of 120. And I get that again. So I get C equals 7 sine 15 all over sine of 120. And I'll do that on my calculator. So 7 sine of 15 divided by sine of 120, and we get 2.09. Alright, next is we're going to look at another case. Our other case is Anglesideangle. So let me show you what that looks like. If I were to draw a triangle out, I would have angle. I would have the side in between the two angles. Let's see if this is going to be a different approach. Well, let me label what's given to us. So alpha, beta, gamma, A, B, C. Okay, we have alpha, we have beta, and we have C. Oh wow, in this case we don't have a pair to begin with, right? But what do we have to solve for first, or what could we? In the same position as example 2, we are able to solve for gamma by knowing that these three angles should add up to 180. So I go 180 minus 85 minus 30, which equals 65. And now I have my pair that's going to allow us to do law of sines. And the good thing is, you want to double check, since I'm using this pair, and as you can see I wrote down 64. If I had kept 64 here, both of these answers would automatically be wrong because I need to use this pair. So make sure you double check what that angle is. Alright, now we do the same thing we did before. So we're going to solve for A, put my unknown in the numerator. So that means my denominator is sine alpha, which in this case is 85, equals, and I've got to use my pair, otherwise I have two unknowns. So I'm going to put the side C on top and sine gamma in the denominator. I'm able to solve for that again just by multiplying the top by sine 85 over sine 65. Do that on my calculator, and that comes out to approximately 5.77. Do the same thing for B. So B over sine 30 equals 525 over 65. So B equals 525 sine 30. Oops, I wrote something down wrong because I'm going too fast. What needs to go with that 65 there? Remember, it's an angle, so you have to put sine with it. That is a common mistake. When I put this in the calculator, we get 2.90. I want to show you another trick, guys, to check your work. Angles and side lengths always have a connection. So your longest side should be with your largest angle. That goes for your smallest too. Your smallest side should go with your smallest angle. We can double check that. 85 is our largest angle, and what do you know? Side A is our largest angle. Our smallest angle is 30. Our smallest side is B. So see how they match up. So this is a quick way to check your work. If it doesn't work out this way, you know you did something incorrect. Now, last year we talked about the ambiguous case, the angle side side. In about 9th grade, 8th or 9th grade, we had proven that we couldn't have similar triangles that had an angle and two sides right next to each other the same, because we could actually end up creating two triangles with the same angle and two sides. Okay, so the idea here is that you can create two triangles, this larger one or this inner one, just based on angle, side, side. So our angle would be this C1, our side would be this A, and what you might not be able to see is that this side C and this side A are actually the same length. What happens is it changes these two angles and it changes this side length. So we have one triangle right there and the second triangle with the same angle side. So there could be two triangles. Does there have to be two triangles? No. So how can we tell this? Well, we have a test, if you remember from last year. What will happen is that we will be solving for an angle first, because I mean we only have one angle. So we're going to solve for an angle first, and when we solve for that angle, we're going to check it with this test to find out if there are one or two triangles. So we have, what we do is we take 180 minus the angle we had just found using law of sines. And then we're going to add that number to the angle given. If this value is greater than 180 degrees, there is only one triangle. If it is less than 180 degrees, there are two triangles. If there are two triangles, guys, it just means we have to solve more for that. So let's do some examples now. Alright, so let me set up my list. So I have alpha equals beta equals gamma equals A, B, C. We are given alpha is 30, A is 1, and C is 4. Okay, so if we look at what's given to us right now, and I just said to you, well, the first thing we're going to have to do is solve for the missing angle to make another pair. Which are we going to solve for? Well, we can't solve for any of the b's or beta because we would have two variables in there. So we must solve for gamma. Okay, remember I said whatever you're solving for, put into the numerator. We're solving for gamma. But let's keep in mind that anytime you solve for an angle, you must add on that trig function. It's the only way to solve for an angle is having that sine of that angle. And then that's going to be over the side 4 equals, we're going to go sine of alpha, which is 30. Since I put an angle in the numerator here, I must put an angle in the numerator there, over 1. Alright, so let's start solving for this. I get sine gamma equals 4 times sine of 30. And then how do we get rid of that sign? Well, we do inverse. So I got gamma equals the inverse sine of 4 sine 30. Alright, well, let's check this out. When we plug this in, we have inverse sine 4 sine 30. Oh no, it says domain restriction. What does it mean by that? Why can't we do this? Well, let's break this down further. Let's actually do 4. Let me get out of here. 4 sine 30. 4 sine 30 is 2. But what is the domain of an inverse sine? Well, so let me write that down so you guys see what I'm talking about. Inverse sine, right? That domain is from -1 to 1. Remember, it's the first and the fourth quadrant. Well, does that include 2? No, it doesn't. Because it doesn't include 2, that means it can't work. So there is no triangle. We cannot make a triangle with these 3 measurements. Okay. Alright, so let's move on to the next one. And before I move the camera down a little bit more to show my work, notice I'm going to keep alpha. I'm going to keep side A. Well, I'm changing side A, but I'm keeping side C. Okay, so we're just changing it a little bit to see how the results change. So let me write all this in. A, B, C. Alright, so we get 30, 2, and 4. Alright, so we're going to do the same setup we did before, so I'm going to go through it just a little bit quicker. I end up having sine of gamma all over 4 equals sine of 30 over 2. Now when I solve for that, of course, in my calculator, I'm going to end up putting the inverse sine of 4 sine 30 over 2. If you have to do it step by step, do it. I'm just going to go through it a little bit quicker for notes. And if we plug that in, we get that gamma equals 90 degrees. Now this is usually where we will do our test. I'm going to do it anyways, but then let's talk about why we wouldn't have had to if we thought about this. So on the side, I'm going to put my test down. So remember, the test is 180 minus the angle we found, plus the angle we have, which equals 120. So the test tells me there are 2 triangles. Now when there are 2 triangles, okay, because this is less than 180, so 2 triangles, the new triangle's gamma would be the subtraction of 180 in that angle. But wait a second. The gamma before was 90, and the new gamma is 90. Those are the same thing. This actually makes sense that really there's not 2 triangles because we can only have one particular right triangle given 3 pieces of information. So when your angle is solved and you get 90, if you want, you don't even have to do the test because the test says 2 triangles, but it's going to give you the same exact triangle. Alright, let's work from here. At this point, if we are having 2 angles, we can now find the third angle by subtracting from 180. So we get beta is 60. And now we can solve for b. b is our unknown, so I'm going to put that on top. And in the denominator, put sine of 60. Of course, I'm going to use my given pair, just in case. So I get side 2 over sine of 30. And here I solve. When I solve for this, we get approximately 3.46. Okay. Hopefully you can walk away knowing that even though we do the test and it says 2 triangles, that these are exactly 1 triangle, because we could have no other way that we have these 3 given pieces of information and 90 degrees and have something different. So what's going to happen with the next one? Well, if you look here, guys, our A just got 1 more bigger. So let's write our given down. A, B, C. So we are given 30, 3, and 4. How is this going to change? Well, let's remember that we are solving for the gamma angle first, so start writing that out. So we end up getting, let me just write that down. We have sine gamma over 4 equals sine 30 over 3. When we do all that algebra, we get this gamma equals sine inverse of 4 sine 30 over 3. And what do we get when we get that? Well, we get approximately 41.81. So I'm going to put that here, 41.81. Now here we have to do the test before we continue. Okay, so let's write down that test. So we have 180 minus the angle we just found. Okay, and that gives me 138.19. Now we're going to add the angle given, which in this case is 30. We end up with 168.19. Ooh, that is less than 180. So there must be 2 triangles. So how do I write that? What happens there? Well, what I have tended to do in the past is I'm going to write these values down, the given values down again, but I'm going to do prime. So alpha prime, beta prime, gamma prime. Because if all of a sudden you write down alpha, beta, and gamma, you can't say that they equal the same if you're dealing with 2 triangles, because then you don't know which one's coming from what. So the first thing I'm going to do is write down my given again. So that's where the extra color helps me. So I'm going to write this 33 and this 4. Now, gamma, I do not write down the same because there is a new gamma. The new gamma comes from where you subtracted from 180. So the new gamma is 138.19. Okay, what does that mean for us? That means we just have to do more calculations. Okay, now you can choose to finish one triangle and then do the other. You can choose to do both the betas first and then both the B's. That's going to be up to you. I tend to, so I don't get confused where to put my numbers, is to finish one full triangle now and then do the other. Okay, so let's finish one full triangle. And when I subtract both these angles from 180, I get 108.19. And then I do my sine stuff again. So remember, I am solving for b. b over sine of 108.19 equals 3 over sine of 30. Well, when I do that, I get 5.70. Take a moment, see if you can do that on your calculator. Everything looks about right. Smallest angle with smallest side, largest angle with largest side. Now I'm going to come down here. I can see that when I subtract 138.19 and 30 from 180, I will get 11.81. And so let's set this up again. Now watch, when I write my work, if I had written b over sine of 11.81 equals 3 over sine of 30, and we were to come back and check our work, it might be a little bit off of like, hey, where did I get those numbers? What does that go with? But if I label it B prime, I know that goes with the second triangle. And when I do that, I get 1.23. Wow, crazy. For our second triangle, our largest angle actually became our smallest, and it changed our sides. Alright, one more problem, guys, because we've learned that we can have no triangles. We've learned that we can have one triangle if it's right away. We've solved for 2. Let's see what happens here. Beta, gamma, let's see, A, B, and C. So we're going up again. We have 30 for our alpha, 4 for our A, 4 for our C. Guys, I want you to make a guess here. What do you think is going to happen? What do you notice? Hopefully you've noticed that these two side lengths are the same exact length. So what are you going to assume? I'm going to assume that if the side lengths are the same, so are the angles. Just like the largest angle goes with the largest side. The sides are the same, the sides are the same. Now, one wrong judgment is if you say, oh, this angle is half this angle, so that side must be half side. That is incorrect. You cannot make that judgment. So let's see if it actually happens. So we're going to go sine of gamma. Don't forget that sine is always with that angle. Over 4 equals sine of 30 all over 4. Okay, this time I'm just going to write it down because we're almost done with our lesson. So in our calculator, we're going to write inverse sine of 4 sine 30 all over 4. And when you do that out, what do you know? We get 30. Now, we still have angle side, so it means we have to do the test, guys. So you only have to do the test when you have angle side. So let's do that test. We get 180 minus the angle found, which is 30. So we get 150. And then we add our angle given, and we get 180. There is nothing in there that says anything about equaling to 180, but the truth is that means there is only one triangle. So since there's one triangle and I identified it as one triangle, I can just fill this in now. So 180 minus 60 is 120. Now I can actually write my other stuff. So b over sine 120 equals 4 over sine of 30. When I solve for this, I get b is approximately 6.93. Now we just increased a each time. Okay, so if you keep increasing a and c stays the same, we're probably going to stick with one triangle. In your work, I want to see if you are doing open-ended questions, we would want to see that test. Okay, no matter what, you have to test for angle, side, side. Okay, we still have that pair. Okay, try that out.